Okay, good afternoon, everyone. I'm originally from upstate New York, and I live in Northern Virginia now, and it's really nice to be back in a city where I can get a good slice of pizza. And that'll be my dinner tonight as well. So I'm going to give you a little bit of background on where I'm coming from and like how I see the world shaped by my experiences. I started my career at General Electric. So talk about the opposite of decentralized manufacturing, a $100 billion company that makes a lot of money by centralizing operations, running Lean Six Sigma to squeeze out every bit of profit. I was a material scientist there, worked on mainly metallurgy projects, new alloy development, new process improvements. I came to DARPA about 2 years ago, and my portfolio at DARPA revolves around materials and manufacturing. I'm going to hit on one specific project later that I think dovetails with what we're talking about here today. But I was asked to answer the question, why decentralized manufacturing? Right? Not why not, but why. And so I'm going to be optimistic, and I'm going to try to think big and talk about the benefits. There's two sort of glib answers. One, because we can, and two, because the people want it. But if we drill down a little bit more into into the whys, I think there's three. There's three things. One is you can enable local function from local materials. So depending on where you are, even within the US, if you're East Coast, Midwest, Rockies, West Coast, we have different styles, different wants and needs, depending on those localities and the kind of lifestyles that people live. You expand that globally, it gets even more diverse. And so, why are we trying to standardize our products? Right? It's because of the economies of scale you get with centralized manufacturing. With decentralized manufacturing, you can kind of scrub that. You can make products for that local environment to sell into the market. Early example of this, it's not decentralized manufacturing, but Toyota was a really game changer in bringing their production facilities over to the U.S. A decade or two ago. There's at least 10 major Toyota manufacturing plants in the U.S. And one of their VPs, commercial VPs, says, we need to make our products in market to sell to that market. And so if you look at an analysis of the Toyota Tundra pickup truck, it's actually more American than the Ford F-150. 60% of the parts in that truck are sourced from the US, as opposed to about 30 in the F-150. So that's a sort of, I think, the beginning of what decentralized manufacturing could look like from an industrial manufacturing leader like Toyota. But I think there's because we can piece behind this, tools like generative design, right? Where you don't need to start from the design, you start from the function. Here's my boundary conditions. Here's what this component needs to do. We have tools now that can, in an instant, design parts that will satisfy those constraints and requirements. And on top of that, we have new manufacturing methods like additive that can go build it right next door, right? And so we are less, held to the old constraint of I need a huge CapEx factory that gives me economy of scale to make a lot of the same parts every day, to one in which it might be economical to make individualized parts to sell into the markets where they're needed. There's also an environmental impact to that local function. I recently read that Maersk is projecting 15 to 20% decline in capacity through the Red Sea in the second quarter of this year because of everything that's going on there. And they're rerouting ships around the Cape of Good Hope at 40% higher fuel burn. So there's that obvious one where if you can make stuff locally, you can drive down not only supply chain risks, but the environmental impacts of shipping. The second of the three things is lead time. We are all impatient, right? When I go on Amazon, I want it tomorrow, if not today. The same thing is true for the DoD. The same thing is true for everywhere. We want same day production, same day delivery. And the DoD is increasingly focused also on point of need production. Contested logistics is the word the Pentagon likes to throw around, where maybe I can't or I don't want to bring with me all of the spare parts, all the munitions, all of the tools I might need. I only want to make those things when I need them, where I need them. And so this dropping the lead time, sourcing things locally, is another motivation for a decentralized approach to manufacturing. Some of the one of the big enablers here is this concept called convergent manufacturing. National Academy of Engineering did a study on this in 2020. Convergent manufacturing, if you hadn't heard of it, is bringing together heterogeneous materials and manufacturing methods. So that could be additive, subtractive, transformative, into a single location. And so you can think about it as some people could talk about as micro factories, right? Where you can build flexible products in one platform that can be shipped around the world. I think that's going to be and is going to continue to be a key enabler. The last one's innovation. So we had a lot of interesting discussions this morning. Big companies like where I come from don't want to disrupt themselves, right? So incremental sustaining technology development is the name of the game. How do I squeeze out a couple more percent efficiency, or how do I take 10% cost out to keep my business competitive? The truly disruptive ideas generally don't come from big industry. But if we have a more decentralized manufacturing approach, disruptions come from where things are produced. And so I think it will only foster more innovation if we distribute that, the production. Now, that's not to say that decentralized manufacturing is going to work everywhere. It's not a silver bullet. And I'm not up here to talk about why it can't work. There's certainly lots of challenges, IP, quality control, geopolitical factors. I mean, you can make an argument that free trade is doing a lot to actually hold the world together. What happens when you cut those ties? And just the true nature of a competitive market, you can start to try to decentralize, but quickly those that are most efficient or best at producing something are going to try to take over, right? How do you combat those? Again, I'm not here to talk about the downsides. I'm here to be a little bit more optimistic. So let me end by talking about DARPA and how we can actually do something about this rather than just talk about it. If you don't know, DARPA is the Defense Advanced Research Projects Agency. It's the high-risk R&D organization within the DoD. We work on things that are potentially impossible. We take big, high-risk swings, and we are not only do we embrace risk, but we require it on our programs. And so you can think of DARPA sort of as a pre-VC funding opportunity. All right, things that you don't necessarily need to have your business model figured out because that market may not even exist. The way you engage with DARPA, we are nothing more than a collection of people called program managers like myself. There's another one sitting in the audience, Vishnu. Raise your hand. You can bug him later today. The secret is find a program manager that's in your domain and email or call them and have a conversation. Because if you have a truly breakthrough idea that is potentially too risky for even the VC folks to listen to, that's the kind of sweet spot where DARPA engages. So I encourage you, come chat with me, chat with Vishnu, go to darpa.mil, look at the offices that we have, look at the expertise of the program managers, and get engaged. Thank you very much for your time. Looking forward to getting to know you.